And the other thing is that the object was relatively big, possibly tens of kilometers, the size of Manhattan Island. And if that's the case, it was a million times more massive than the previous objects from outside the solar system, and that was puzzling.
In a groundbreaking new analysis, Harvard astrophysicist Avi Loeb and his colleague Eric Kito have dissected a Hubble image of the interstellar object with startling results. What was previously thought to be a simple, fuzzy coma of gas and dust is, in fact, nothing of the sort. The glow of scattered sunlight surrounding 3I Atlas is a dramatically elongated structure. It appears to extend twice as far from the object towards the sun than it does in any other direction, sideways or trailing behind it. This sunward extension represents a profound physical puzzle. It is, in effect, an anti-tail. This discovery stands in stark, direct opposition to the magnificent tails of scattered sunlight that are the defining hallmark of common comets. The physics governing cometary tails is simple and has been understood for centuries. Fine dust particles, with a size similar to the wavelength of sunlight itself, are physically pushed by the pressure of solar radiation. This gentle but relentless force sweeps the dust away from the sun, causing all comets to display magnificent tails that point directly away from our star, like celestial windsocks billowing in the constant solar breeze. If this is the established, unbroken rule of cometary physics, then the question becomes unavoidable. Why does 3I Atlas so blatantly defy it? Why is its primary glow pointing directly into the wind? What makes this discovery even more extraordinary is the geometry of the observation itself. The critical Hubble image was captured on July 21st, earlier this year, when the line of sight from Earth to 3I Atlas was almost perfectly aligned with the line connecting 3I Atlas to the Sun. The angle of misalignment was a mere 10 degrees. This means that Hubble was viewing this elongated glow almost perfectly edge-on, a perspective that would dramatically foreshorten its true extent and hide its shape. Imagine trying to appreciate the length of a spear by looking at it from directly in front of the tip. You would see only a point. After applying a simple but crucial geometric correction for this unfavorable projection, a mathematical factor to account for the shallow viewing angle, an astonishing conclusion emerges. If we could pilot a spacecraft and position it to observe 3I Atlas from directly above, looking down on its path, we would see its sunward glow extending an incredible 10 times farther towards the sun than it does in any other direction, sideways or trailing behind it. This reveals a staggering 10-to-1 aspect ratio, a razor-thin blade of reflected light aimed directly at our star. This is a remarkable extreme elongation that was not discussed or even noticed in the scientific literature prior to Loeb and Kito's new paper. So what could cause such a strange phenomenon? Their working hypothesis is that this glow is not caused by the fine refractory dust common to all other comets. Instead, they propose it is created by larger, more substantial ice fragments. These icy chunks are being violently shed or kelved primarily from the superheated sun-facing side of 3I Atlas. As they are launched into space, they are steadily evaporated by the intense sunlight. The largest of these ice fragments, particularly those launched directly sunward, would naturally survive a much longer journey before disappearing completely. This process would create a long, thin trail of reflected sunlight that stretches 10 times farther in that direction than in any other. There may be other explanations for this tenfold extension, and the scientific community will surely debate them. But one thing is absolutely clear. The existence of this feature is entirely unprecedented, and it demands a rigorous physical explanation. This strange anti-tail, however, does not exist in isolation. As Professor Loeb explains, it is simply the latest clue in a growing case file of strangeness, a file that suggests 3I Atlas is unlike anything humanity has ever encountered before. It is not just one anomaly, it is a collection of them. 5, to be exact.
First on that list is its improbable path.
The trajectory of 3I Atlas, while moving backwards against the flow of the planets, is almost perfectly aligned with the ecliptic plane, the flat disk where all the planets orbit. The alignment is precise to within 5 degrees. The probability of an interstellar visitor arriving on such a specific, constrained path purely by chance is a mere 1 in 500. This is no abstract coincidence. This specific path is what brings 3I Atlas into close proximity with Mars, then Venus, and then Jupiter, all in a rapid sequential tour of our solar system. Second, there is its colossal size. The latest and most rigorous analysis places an upper limit on its solid nucleus at an immense 46 kilometers in diameter. If this is even close to its true size, it would make 3I Atlas 1,000,000 times more massive than 2I Borisov, the only other confirmed interstellar comet we have ever had the chance to study in detail. We will soon have a critical opportunity to resolve this. On October 3rd, the powerful HiRISE camera aboard NASA's Mars Reconnaissance Orbiter will be in a perfect position to image 3I Atlas as it makes its closest approach to Mars. With a pixel resolution of just 30 kilometers, that observation will provide our best yet constraint on the true, and perhaps terrifying, size of this object's nucleus. A monstrous object on a targeted path, exhibiting physics we've never seen before. And this is only the beginning of the mystery. The case file on 3I Atlas is now open. We have a colossal object, potentially 1,000,000 times more massive than any other interstellar comet we've ever seen. It is moving on a statistically impossible trajectory, a path that appears tailored for a planetary survey. And as we have just seen, it is surrounded by a 10-to-1 razor-thin extension of light aimed directly into the pressure of the sun, a feature that defies our fundamental understanding of cometary physics. Each of these facts, on its own, would make 3I Atlas a once-in-a-generation object of study. But the anomalies do not stop there. The next 2 pieces of evidence in the case file move beyond the object's motion and shape and into its very essence, its chemical makeup, and its unique interaction with light. The third anomaly on the list is its unprecedented antitail. As our new analysis shows, for months after its discovery, while at a great distance from the Sun, 3I Atlas displayed a glow that extended towards our star, not away from it, with the true scale of a dramatic 10-to-1 elongation, a feature never before observed for any comet. The fourth is its unprecedented chemistry. When astronomers turned the world's most powerful spectrographs on the plume of gas surrounding 3I Atlas, they did not find what they expected. Typical comets from our solar system are water-rich. They are often called dirty snowballs. But the gas coming off 3I Atlas is strikingly, overwhelmingly dominated by carbon dioxide, making up 87% of its mass. Water is just a trace component, barely present. But beyond this, 2 more chemical signatures were found that are deeply puzzling. The first is the presence of nickel, but without its common geological partner, iron. This is a chemical separation not typically found in natural asteroids or comets, but it is a known characteristic of some industrially produced nickel alloys. The second is the detection of cyanide, a common cometary molecule, but with a bizarre behavior. Its concentration in the coma rose sharply as the object got closer to the Sun, far more than standard models would predict.
The fifth and final anomaly is perhaps the most technical, but also one of the most profound. It's unprecedented polarization. When sunlight scatters off a comet's dust, the light becomes polarized, just like when it reflects off the surface of a lake. By studying this polarization, scientists can learn about the structure and composition of the scattering particles. Every comet ever studied, whether it originated from our own solar system or from interstellar space, fits within a known range of polarimetric behavior. 3I Atlas does not. It is characterized by an extremely deep and narrow negative polarization with a very low inversion angle. To put it simply, the unique fingerprint of the light it reflects is fundamentally different from all known comets. It is the very first object ever discovered with this specific and anomalous combination. This bizarre polarization might be the direct result of the extreme 10-to-1 aspect ratio of the scattered light around it, a direct physical consequence of the antitail we are only now beginning to understand. This is the case file. 5 powerful, distinct anomalies, each one pushing the boundaries of our understanding. In the existing scientific literature, there is a natural conservative tendency to address each of these puzzles individually. They are explained away as quirks, shoved under the comfortable carpet of traditional thinking, trying to force them into a familiar context of a dusty, water-rich comet, even if the evidence does not fit. This mindset is not surprising. It is a human one that has guided thinking for millennia, perfectly summarized by Ecclesiastes 1:9. What has been will be again. What has been done will be done again. There is nothing new under the sun. However, when you stop trying to explain away the evidence and instead view it in its totality, a different conclusion becomes possible. The combination of an improbable path, a colossal size, a physics-defying antitail, an anomalous chemistry, and a unique light signature argues for something more interesting. It suggests that perhaps we are looking at something genuinely new. The job of science is not to assume that what has been will be again, but to test that hypothesis against the evidence. Let us commit to harvesting as much data as possible from 3A Atlas with every available telescope on Earth and in space, because we may be on the verge of discovering something truly new under our sun. It is conceivable that Ecclesiastes, like any human, was wrong. Our path forward, therefore, must be guided by a different, more powerful creed, one that serves as the foundation of all true discovery. We must question everything.